Hello. Okay, cool. So, hi guys. So this is the day two of um, our session in which we'll learn about forward and inverse kinematics. Okay. So so let's say while designing our manipulators, what happens is we need the angles between all the links. How it should be, what should be the angles and the orientation and the positions. So, can anyone tell me? Hello, first of all, I want you to guys to unmute your mic यार. Unless and until किसी का ज़्यादा disturbance आ रहा है, he can be on mute. Unmute your mic, sir. Please unmute your mics. Hello, hello. Yeah,
Hello.
yeah. Hello. Good, good. Mushi, Praneet. Yeah. So, ये
Noise.
कोई बात नहीं यार. Tell me, Mushi. Okay, let's start with you, Aaron. What do you mean by kinematics, यार? ये सब तो करके आए हैं आप लोग. Kinematics. हाँ.
बेसिकली अपन स्पीड और वेलोसिटी न्यूटन लॉस ऑफ मोशन यूज कर करके उस पे मतलब उसको यूज कर करके अपन निकाल सकते हैं मतलब पोजीशन में कहाँ पे क्या होना चाहिए.
Okay. Anyone else? Siddharth. What is kinematics?
Study of motion, any
Hmm.
sort of.
Yeah. So, what else? अगर मैं उस पे 2 न्यूटन का फोर्स लगा रहा हूँ तो कितना डिस्प्लेसमेंट होएगा वो सब भी आएगा उसमें क्या?
Mm, it is, I guess, it is more related to the effect of it rather than the cause of वो. So वो हम लोग अलग से forces और उसमें पढ़ते हैं. The causes, maybe effects ज्यादा हम kinematics में पढ़ते हैं.
Good, good. So we won't consider that all those things. It is just about pure motion, nothing else. Okay. Uh, good, good. So अब kinematics का करते हैं. Let's अभी कल yesterday you studied about what is forward and reverse kinematics in the arm manipulators. Can somebody please give me what was it? Hello, hello.
Oh, reverse kinematics, we are given a position and we are given some sort of destination, and in itself, we have to figure out how we reach that position. Rather than
Uh-huh.
forward kinematics, we try to determine कि मतलब खुद से ही ये करके कि how like given this step after this step उसमें फिर क्या क्या आगे आगे होना चाहिए.
Okay, so itna bata diya aapne. Explain me with this diagram, like what all value should be given to us and what we need to find out in this forward kinematics. Tell me.
एक बार वापस
Praneet,
क्वेश्चन.
you, Praneet, hello, Praneet,
Yeah.
Prateek. Yeah, Praneet, tell me what was forward kinematics यार, थोड़ा सा please. उसके बाद we'll
So
start.
forward kinematics, we have the length of linkages, the angles, everything, and then we
Mm-hmm.
calculate the position of the end effector from that.
Cool. Okay, good. Yeah, this was only the forward kinematics. Yeah, we will be having all these values in the forward kinematics, the values of the relative angles between the links and the length of the links also. So we'll put these values in the equation. We'll calculate its projection on the x-axis, y-axis, and z-axis. We'll calculate the position of the end effectors. Yes or no? Everybody agrees. Okay. कोई भी डाउट, एनी डाउट यार, इन केस एनी डाउट यू आस्क मी उसी टाइम ही अनम्यूट करके, ओके. So we'll have all these values given to us between the links, and using those values, we'll put those in the equation. What will be the equations? We'll directly project those on x, y, and z axis. We'll calculate the uh, position of the end effectors. This was very simple mathematics which we did in 11th, 12th class. Yesterday also we did the same for we did, right? Yes or no? कल कवर हुआ था ना ये?
Hmm.
Hello. Yes. Okay. So okay. So what was here in this? This is a 2 degree of this is a 2D of robot. What is this? This is serial chain. Okay. These are all in series, connected in series. Okay. So what happens is we'll calculate the projection and using simple projection. Um, right angle triangle may the base will be L1 cos theta, or height will be L1 sin theta. So we'll add those and we'll get these X, Y, and Z values. Okay, this is in 2D given, or let's say if the robot is in 3D, which will take it aage in the session. So this is how we calculate for 2D. And similarly for 3D also, it's very simple. The angles, tell me all these angles, why the angles are getting added up here, theta 1, theta 2, theta 1, theta 2, and theta 3. Yeah, what is the Durva Daga? Yeah, tell me, Durva Daga. Durva, what is this? Why these angles are getting added up? Yeah, I think. Okay. Musi. Okay, no problem, Durva. Yeah. Musi.
Like these all angles we can like clearly see in the diagram that like the angle that we're having is like adding up due to the like this like theta 1. For theta 2 we'll have to add, like theta 2 there is also a theta 3 that should be added if we like interpolate like extrapolate the line joining the linkage line.
Okay, that's the simple thing is here we'll take it with respect to x-axis. The angles will be taken with respect to x-axis, or they will keep on accumulating, means they will keep on adding up. Okay, yeah, good. Okay, so this was about this is all about the analytical solutions. Okay, uh, these are called the analytical solutions. So now when we'll code it, what happens when we'll put this in the our programs? So this may take time. This may take quite lengthy calculation or lengthy codings. So what we do, we use the algebraic solutions or in the form of matrices to calculate. So what we do, we use the matrix solution, algebraic solutions to calculate the solutions of the end effectors. Okay. So there is an approach which we call is that uh, Danawit-Hartenberg parameters are used here. It is a kind of um, orthonormal matrices. We use the orthonormal matrices to calculate the positions. We'll learn about these matrices. So in this approach, what happens is we have between two joints. See in the highlighted with the pink color, we have between two joints, we'll take four parameters. Okay. Between two joints, any two joints will take four parameters will be taken. That four parameters will be used to do the calculation of the positions. Okay. Let's say, suppose, so itna samajh aaya ki what are we doing? These are all the analytical solutions. These are all the analytical solutions. Now, to do it in the programming, we use the algebraic solutions so that the calculation becomes easy, and uh, the the robustness of the program increases. Okay, so see, this is a 4 cross 4 matrix will be taken. Okay, orthogonal matrix will be used in these. This is most used technique in robotics. Okay. So what happens is there are four variables will be taken, not four variables, I think four constant. The four parameters will be taken between two joints. Okay. And those parameters will be used to calculate the positions of the joints, and that will lead to the position of the end effectors. Okay. Now it can be very easily used for any configuration for any degree of freedom. Okay. Let's say agar wo in mostly for 3D also can be used. Okay. In 3D also it can be very easily be used. These are all in the 2D. Okay. ये सब अपना 2D में था, whichever in X and Y axis it was there. But let's say suppose we have a diagram like this. See, this is in 3D now. Okay. So this is the reason why we are studying this method. It becomes very easy to solve once you understand this approach. Okay, so in short, we will say it as DH. DH parameters will use the DH parameters to calculate the position and orientations of uh, the end effectors. This will consequently, this will at the end, this will lead us to the result, what will be the orientation and the position of the end effectors. Now see, before moving further, I want you to show this code. I have taken one example. I'll I'll show you further. And I put those values in this code. And what I got here is, can you see this clearly in the blue box here? In the blue box here, we have position and orientations, the value we are getting here. This was the result which we got after putting the values. These all are the values, the four parameters I have put here. Okay. These are the parameters values which I have put here. The angles, the length of the links, all those values I have put here. And after that, this is the matrix, the orthonormal matrix, the transformation matrix, which is being used to code. These all are the functions designed so that I can use this code again. Okay. So after learning this approach, you will be very easily, you will be able to design this code. And it is very easy to understand once you understand the approach. Uh, okay, let's move and let's learn this process. So the main thing is remember what is DH, DH parameter, DH approach will be used, and we will put DH parameters on that. Okay, there are four DH parameters. See, now let's move to the DH. What are those DH parameters? Okay, before that, I want. Okay. So Pratik, Shambhu, yeah,
Yeah,
are you available? Yeah, bro.
yeah.
Tell me, what all can you understand from this diagram?
There's, I think,
आपको समझ आया what I have explained before the DS parameters and all those?
uh,
आ गया ना? Okay, ठीक है. उनका इससे अभी कोई लेना देना नहीं है. I'll explain it. Just tell me what can you see in this diagram?
so it looks like there are two linkages, one joint and two bases that are connected and grounded. Um, and is it like there is a rotational freedom at one joint, at the middle joint? Um,
Okay, okay, good to go. Yeah, Siddharth and Siddhant, tell me, what all can you understand? What are the different things you are able to see in this diagram?
Yeah, I guess similar to what we said actually. Uh, as in the middle one can twist about something of that sort because it is already in a tilted position. So probably both those endpoints are not uh, fixed. They must be movable or something. But like I don't understand why it is done in this position. Like I could not figure out any exact purpose specifically for which it is in this
Okay,
position.
chill. Okay, let's see. First of all, yeah, we have these three. Let's say if these are the servo motors. Okay, so first of all, this, this, and this all have their own frame of reference. They all have their own frames. Okay, okay. उसके बाद we have used the nomenclatures. Let's say xi minus one, zi minus one, yi minus one. For this, we have used xi, yi, and zi. And for this, we have used xi plus 1, yi plus 1, zi plus 1. Okay. We'll go step by step. Okay. This was about the frame. Now, between these two frames, the length of the link was taken a minus 1. And after that, it was taken ai. Okay. Ai minus 1 and ai. These are all the standard things we have taken. Now, what is now this is alpha I minus 1. What is this alpha I minus 1? This is the angle between this zi minus 1 and zi. Okay, the alpha I minus 1 angle. And this theta angle, what is this theta angle? Hello? Hello. So this theta angle is the angle between zi minus 1 and zi. Okay, so whenever there will be rotation in 3D, all the angles will change. Okay, so that is only shown here. Okay, so these are the parameters, the four parameter. The this one is also left. Di minus one. Yeah, this one is di. This di is the uh, distance between this frame and this frame. Okay, that is di. We have taken QKV. It is not clearly visible from here, but between this frame, one frame and second frame, the angle between them is the length between those frames is di. Okay, as it is di is the angle is the distance between these two both these frames with respect to where it is. Huh. Okay. So this is di. Di is the distance between the both the frames. Okay. Now, what the four parameters, the th parameters are in this only. First is a, second is d, third is alpha, fourth is theta. These are the four parameters, th parameters. Okay. You'll have to remember this length of link, theta angle, alpha angle, or d. These are the four things, th parameters. So we'll transform it. What do you mean by transformation? We in the EH approach, what happens is we transform. Yeah, Siddharth.
Can you please explain what was the D again?
D is the angle between D is the distance between the both the frames. Yeah. Let's say एक
Both
frame
the
ऊपर, let's say one frame. It is like the distance between their center of masses. ऐसे समझ लो. Yeah, it is the distance between their center of masses भी समझ लो. Measured along the x-axis. ऐसे करके समझ लो.
oh, अच्छा, okay, I got it.
So in short, you'll get to know आगे चल के what all these are parameters when you learn through an example. Okay. So first of all, there are four parameters. इसके अंदर DH parameters you can all see it. A, alpha, theta, and कौन सा था D. These are the 4 parameters. Now we'll transform it in a way with respect to base. So base is taken as the reference. Base ke saath we'll transform this. First we will transform this according to the base. Then we'll transform this according to this. Okay. So at last what will happen? We'll get the transformation of the end effector with respect to base. Okay. What are we gonna do? We'll transform this first, then second one, then third one. First one will transform with respect to second one. Second one will transform with respect to third one. Third one will transform with respect to fourth one, and then we'll multiply all. So what we'll get is we'll get the base one transformation, the end effector transformation with respect to the base one. This is the main thing we are gonna do, transforming it. Okay. Okay, let's move to the next slide. This is a very typical khatarnak sa formula. I'll say just remember what it is, or I'll tell you what is this. Rx and Rx is the Rx and RZ represent the rotation matrices, or dx denotes the translation matrix, or इसके अंदर S and C represent the sine and cos angles. You don't have to remember all these things, but आगे जाके I'll tell you just remember this formula, this matrix, this thing. This is the general matrix. You'll have to remember. Don't remember it. Just keep it in mind that this is the matrix, transformation matrix. इसमें what we have done here is we have transformed the I minus one ith element with respect to I minus one element. Okay, let's say suppose the base is this. This is the base. Agar this is the base and the ith element is this one. So what we are transforming? We are transforming this with respect to I minus one. Okay, so this is there. We are transforming ith element with respect to I minus one. Okay, ऐसे करके. So using these matrices for first and second, for second and third, for third and fourth, fourth and fifth, ऐसे करके we'll calculate all the transformation बीच में between those links, and then we'll multiply all to get first and last one to calculate the transformation of end effector with respect to base. Understanding, yeah, सबको समझ आ रहा है ना what I am saying? This is a little bit थोड़ा सा हो सकता है ऊपर नीचे. Yeah, guys, ask यार.
This matrix is transforming from like from I minus 1 to I plus 1. Or is
I
it like
minus one to I minus one to I, or I to I plus one. Alternatively, we'll transform it.
Acha, every alternative.
Yeah, continuously we'll transform it. Yeah.
So basically, we have the 4 parameters, right? D, A, alpha, and theta.
Yeah.
So if we find the transformation matrix from the first base to the final base, and we
Okay.
apply this transformation matrix to the inputs of the first base, we're supposed to get the parameters of the, like the alpha.
I'll
X.
explain you the flow. How we will use these parameters to get the transformation of the last end effector with respect to the base. Okay. Okay. This. I'll explain you. सब समझ आ जाएगा. And that you just remember this matrix. Okay. ऐसा बस दिमाग में रखो कि that this is the matrix. Hey, one second. Okay. Just keep it in mind that this is a matrix. और ये जो है ना 0 0 0 1, this will always remain the same. चाहे whatever transformation you are doing in DH approach, this will remain the same. 0 0 0 1. ये last वाला row हमेशा will be 0 0 0 1 रहेगा. इसको हम we use it for the homogeneity of the matrix so that it could be easily be multiplied. ऐसा करके है. We'll आगे चल के let's see how we are. See the question which you were asking, Alu, this the transformation of end effector with respect to base what we'll do it in step by step. We'll use the between 0 and 1, then 1 and 2, 3 and 4, 4 and 5. ऐसे करके we'll use and we'll multiply all those transformation to get the transformation between t 0 and t and effector. Base is considered as 0 basically here and end effector is n here. Understanding here, guys? Yes or no?
Yes.
Easy?
Yes.
Yes.
पक्का आ रहा है ना समझ? यार नहीं समझ आ रहा तो भी बता दो
Yes.
मेरे को. ठीक है, अभी मैं तुमसे लास्ट में कोड करा के देखूंगा, पता है. I'll make you to write the code, okay? And I'm very sure that all of you will be able to write the code because this is gonna be very easy. Okay, अभी अगर ये समझ आ जाता है तो the code is very easy for you to write. Okay, so let's say suppose सब कुछ multiply करने के बाद after multiplying all those things, everything, multiplying n number of transformation, let's say suppose we have n number of servos between the arms. So सबको multiply करने के बाद we'll get, let's say this matrix we get. ठीक है, suppose we'll get this matrix. Actually में जो हमारे को values मिलेगा वो कुछ ऐसा खतरनाक सा values होता है. These are all the values which we'll get after multiplying. सो हमने इनको शॉर्ट में सबको R11, R12, R13 कर दिया है. ठीक है, बट दिस इज द मैट्रिक्स व्हिच विल गेट. ओके, जनरलाइज कर दिया हमने. अब R11, R12, R13, व्हाट आर ऑल दिस थिंग्स, व्हाट दिस मैट्रिक्स डिनोट. अब अपने को ये भी तो समझना है ना, व्हाट डू यू मीन बाय दिस मैट्रिक्स. अपने मल्टीप्लाई कर दिया, व्हाट आर वी गेटिंग एक्चुअली. सो व्हाट वी आर गेटिंग एक्चुअली हियर इज ऑफ ग्रेट इंपॉर्टेंस. सी what it is, the R1, the first row, the second row, and the third row. These all will give us the coordinate of the new x, y, and z axis. Okay, the first column will give new x axis, the second column will give new y axis, the third will give new z axis. और उसके बाद जो P वाला part था ना, that will give us the position. That will give us the position of the frame. One second. See, the vectors gives the position of the origin of the frame in frame 0. Means with respect to frame 0, what is the position of frame 6? That will be given by the Px, Py, Pz in this matrix. Hello? Are you guys understanding what I'm saying?
Yes.
Yes.
Okay, cool. ठीक है. अब see, why I told you that why we are putting 0, 0, 0, 1 here. So it is for the homogeneity component so that everything can be multiplied and made it in one matrix. That is the main thing. One second. Okay. So अपने we have did all the multiplication. We understood all the what are DH parameters, what is transformation, how we did the transformation, and we'll take an example. We'll take an example of 6 degree of freedom. Let's say, so we'll do with 6 degree of freedom wala. If you are able to solve 6 degree of freedom, bro, you are able to solve everything in forward kinematics. See the level you will get after doing this. Okay. So, okay. Let's say suppose these are all the values given. Okay. First of all, मेरे को इसके अंदर तुमसे कुछ questions पूछने थे. Okay, कोई volunteer करना चाहेगा for me to cross question? Okay, tell me, explain me this diagram, what all values are given, what is rotating and what is not rotating. कोई भी? Anyone? Hello. Yeah, Siddhant, go.
So the base can rotate about. So
Okay, yeah, theta 1 angle is given, good.
and then theta 2 is also given. So that part can also rotate and that part can also rotate so that the top one can come up and down as it turn around. Or फिर बाकी रोटेशन वाले ऊपर ही है, the like the rest like action of that theta 4, so it can rotate and do the rest like action for the end effector. And uh, I don't
देखो
understand इसमें थीटा 4 और थीटा 6 दोनों में तो सेम जैसा लग रहा है, तो एक वो
see theta 4 is rotating in, let's say it is rotating in xy plane, or theta 5 is rotating in xz plane, or theta 6 is again rotating in, yeah, these are all the different joints are there, यार ऐसे
okay.
करके समझो. Okay, we have 6 degree of freedom, so we'll have 6 joints in this. So इसके according they have taken the values of thetas. Okay, so इसमें alpha values given है, alpha values are not given here, so that will be taken 0 only. Okay, so अब आते हैं alpha values पे. Okay, alpha values 90 90. Okay, इसके अंदर okay, it is changing the place ऐसे करके, so that's why 90 degree. I'll explain this कैसे. So theta 1, theta 2, theta 3 is 0.
Use your fingerprints to unlock the device.
Okay. So theta 3 is 0, theta 4 is here, theta 5 is here, theta 6 is here. First is 0 with respect to base. We'll take alpha as 0. Then 90 degree. कैसे आया 90 degree? See, alpha is the angle between. What is the angle? Alpha is the angle between zi minus 1 and zi measured along xi. So इसके अंदर see इसका z plane कौन सा है? इसका z plane is this one, and or zi and zi minus 1 with respect to xi. Here I'll have to see this. Okay guys, यार I'll have to see this. I'll explain you कि ये कैसे आया. मेरे को भी एक बार देखना पड़ेगा ये कैसे आया. So just remember that कि theta 3 इसके अंदर 0 है. I'll tell you how to put this. ai minus 1 इसके अंदर सब में 0 ले रखा है, बट 0 होएगा नहीं. इसके अंदर we'll take the values when we'll take an example ना. इसके अंदर while doing the code we'll take values of the a values we'll take. This is the a values we'll take here यहाँ पे. You'll see. अभी अपन आते हैं what was the transform matrix. अब 0 से 1, 1 से 2, 2 से 3, 3 से 4, 4 से 5, 5 से 6. There will be 5 transformation matrix जो बनेंगी after putting the DH parameters. So DH parameters डालेंगे तो there will be obviously 5 linkages. कितने आएंगे? 5 links आएंगे, so there will be 5 transformation matrix. Okay, तो transformation matrix बन जाएगा and we'll multiply all those transformation matrix. We'll get the transformation of the end effector with respect to the base. ऐसा एक मैट्रिक्स बनेगा. आफ्टर गेटिंग दिस मैट्रिक्स व्हाट विल डू, विल गेट ऑल दी पोजीशंस. ऐसे करके कुछ खतरनाक सी 16 इक्वेशंस बनेंगी. You don't have to do this by hand. Just we'll put the formulas in the code. We'll get the values. We'll do the coding. Loop में डालेंगे उसको. We'll put the matrix in loop. We'll get all these values very easily. Understanding guys, are you understanding कि अल्फा ये सब वैल्यू ये ट्रांसफॉर्मेशन कैसे हुआ? अल्फा यार मेरे को देखना पड़ेगा वो सब. इवन आई हैव टू सी इट. हेलो,
Yes.
Yes.
आ रहे ना, समझ आ रहे ना? चिल्ला ना सीन ट्रांसफॉर्मेशन कैसे किया हमने
वो
विद रिस्पेक्ट टू बेस वी आर ट्रांसफॉर्मिंग. हाँ जी, हाँ जी, यस.
वो अल्फा इज इट लाइक विद रिस्पेक्ट टू द प्रीवियस जॉइंट की, मतलब वो एग्जैक्टली अगर पैरेलल होता है तो फिर उसमें 0 आता है, और अगर ऐसे ऊपर हो तो फिर ऐसे 90.
लेट्स से सपोज इसको हम अपना रेफरेंस मान लेते हैं. एक्स एक्सिस के अलोंग उसने कहा है मेजर करने को. तो लेट्स से दिस इज 190. फिर ये थी थर्ड वाला भी इसी के साथ जुड़ा हुआ है, तो थर्ड वाला 0 होना चाहिए. ओके, और फोर्थ वाला अगेन 90 होना चाहिए, फिफ्थ वाला भी इसी के साथ जुड़ा हुआ है, तो फिफ्थ वाला कैसे है? फिफ्थ, अच्छा इनके बीच में एंगल भी 90 है, तो ये भी 90 होना चाहिए। और सिक्स्थ वाला, यार मैं कंफर्म करके बताऊंगा यार, अगर इफ यू कैन एक्सप्लेन अच्छे से तो मेरे को बताओ थोड़ा।
नहीं, मेरे को मतलब मैं भी ऐसा गेस कर मेरे को मतलब उसमें 90 और -90 है, तो फिर मे बी विद रिस्पेक्ट टू द प्रीवियस जो जॉइंट है, बस कि मतलब दो जुड़े हुए हैं उनमें बस पिछले वाले के रेफरेंस में क्या वो 90 में है या क्या वो पैरेलल है वैसे टाइप्स में शायद, मतलब बेस से
हम्म।
ये नहीं है, बस पिछले वाले से शायद ऐसा।
हाँ, या आलू यार, या हो सकता है यार, बिकॉज एवरीथिंग इज टेकन, या जॉइंट्स के बीच में सब विल टेकन, एवरीथिंग विद रिस्पेक्ट, ये रेफरेंस में ही लिया जा रहा है सारा का सारा। सो व्हाट यू आर सेइंग कुड बी करेक्ट यार, बिकॉज ये सारा का सारा इज टेकन विद फ्रेम्स में ही बात की जा रही है, रेफरेंस फ्रेम्स से बात की जा रही है, तो रेफरेंस में ही लिया गया होगा एंगल भी। दैट कुड बी करेक्ट यार, या आलू यार।
No, I had a doubt, I mean, about the transformation matrix.
या ब्रो।
So if we have a transformation matrix between, let's say, two bases, uh, let's say 0 t1,
ओके।
are we like converting coordinates of one axis into coordinates of another axis?
Hello. Hello. Sorry, yaar. Uh, एक second, yaar. I'll share my screen here. One second. Can you see a presentation slide uploaded है क्या इसके अंदर? Can you see the presentation, guys?
No.
Okay. Now, can you see?
Yeah.
Okay, cool. Yeah, guys, yeah, somebody was asking something. Yeah.
I was asking about the transformation matrix. Like, what does it signify? I mean, I understand that we get,
Yes.
we change the, I mean, are we changing coordinates from one system to another system, one frame to another frame?
देखो, frame of reference will give us the coordinates, है ना? उसके बाद what, let's say, suppose transformation means here we will talk about in terms of position and orientation. Okay. Transformation matrix में position also comes and orientation also comes. What do you mean by position? Tell me first. Position means coordinates. Okay. Yes or no?
Yeah,
And what do you mean by orientation?
angle.
Orientation means the, yeah, in angle also the directions, mainly in which direction, in which angles it will be there. Okay. So yeah, so अपने को ट्रांसफॉर्मेशन मैट्रिक्स से ओरिएंटेशन मिलेगा, द डायरेक्शंस विल गेट, इन शॉर्ट द डायरेक्शन कोसाइंस यार, जो अपने को डायरेक्शन देंगे कि इन विच डायरेक्शन विल हैव द transformation of x axis, y axis, z axis with respect to the base axis. Orientation will give us the direction cosines, and अपने को position will give us the coordinates. कुछ ऐसे करके होगा. समझ आया कुछ क्या आ गया?
Yeah, I understand.
अंडरस्टैंडिंग पोजीशन एंड ओरिएंटेशन यार, मेनली दोनों दोनों का कॉम्बिनेशन होगा. और जो लास्ट वाला 0001 होगा, that will be common for all. That will be common for all to multiply the matrix. Easy हो जाए चलना. Guys, किसी को कोई डाउट आगे, so that we can move further? Hello guys, मैं क्वेश्चन पूछूंगा यार, तुम बोला
Just
करो
one,
यार. Yes,
just one
yes,
more
yes.
doubt. Could you show the previous slide with the diagram?
Okay, bro.
Yeah, here why did we just take the Z2 in the different direction while we took Z1, Z0, rest of them in the same direction?
I didn't understand your question, man. Hello. Hello. Can you repeat the question? Yeah.
Yeah, can you hear me now?
Yeah, I can hear you. Please
Yeah.
repeat your question.
So Z1 and Z2 are perpendicular, but the rest of them seem to be in the same direction. So what's special about Z2?
Z5 also.
Okay. Let's see. X4, Z4. Yeah, there should be a standard rule for taking the references, like I'll say.
But I guess it's like the components which are placed in the perpendicular direction, like where Z naught is given, that is placed in the perpendicular direction, that is assumed to be Z naught. And where it is tilted, there it is taking Z2 in the inside the plane. Like for Z5 also, it is like horizontal, if you see. And Z2 also, that thing is also placed in a horizontal fashion. So
देखो, the very common assumption we take is just the right hand rule, some rule ऐसा होता है ना कि the rotational axis is usually taken as the z axis. मैं तो ऐसे ही देखता हूँ. So इस diagram में which I can see common in all is that z axis is taken perpendicular to the rotational plane. समझ आ रहा है कुछ कुछ? Are you guys understanding?
yes.
Yeah, I think so.
है ना? ये चीज कॉमन है ना? रोटेशन के परपेंडिकुलर इज टेकन एट z एक्सिस. यस. और बाकी सब x और y तो सब एक जैसे ही दे रखे हैं पेंसिल. x और y में अलग है. समझ आया आपको z एक्सिस का क्या फंडा है? यहाँ पे z एक्सिस का सिंपल फंडा है द रोटेशन. रोटेशन देखो किस प्लेन में रोटेशन हो रही है, उसके परपेंडिकुलर विल टेक द z एक्सिस. ऐसा है. और एक्स और वाई का तो वही रहेगा जिस प्लेन में हो रहा है उसके अकॉर्डिंग एक्स और वाई हम लेंगे. अब एक्स कहाँ लेना है, वाई कहाँ लेना है, उसका क्या रहेगा सी. उसका ओके. एक्स और वाई इसके अंदर सिंपल यूज कर रखा है. मेरे ख्याल से राइट हैंड थंब रूल यूज कर रखा है. एक्स टू वाई घुमा रहे हैं तो जेड की तरफ जा रहा है. दैट इज द सिंपल लॉजिक which they have used here. X axis to Y axis will rotate our finger. Z will give us the perpendicular direction. So X और Y उसके अकॉर्डिंग ले रखा है. Z is taken perpendicular to the rotation. Okay, ऐसा है. अब आते हैं ट्रांसफॉर्मेशन मैट्रिक्स में. यार मैं अल्फा वाला आपको देख के बता दूंगा. अल्फा फॉर अल्फा आई एम नॉट श्योर यार. we'll discuss it in the next lecture for sure. ये अल्फा वाला. बट आप ये सब ट्रांसफॉर्मेशन समझ आया. व्हाट विल इट गिव? इट विल गिव अस द ओरिएंटेशन एंड द पोजीशंस. अब इसके बाद गाइस, अब मेरे को कोई बंदा चाहिए हु कैन एक्सप्लेन मी दिस कोड. एक तो मेरे को ये बताए और मेरे को ये समझाए व्हाट इज दिस और कोड. अब आपको देख के समझ आ जाएगा. सी दिस मैट्रिक्स. ये मैट्रिक्स देखो. ये भी मत देखो अभी. ये मत देखो. यू सी दिस मैट्रिक्स. ये वाला बेसिक वाला मैट्रिक्स. दिस मैट्रिक्स, द जनरलाइज्ड फॉर्मूला. दिस मैट्रिक्स वी विल यूज. और इस मैट्रिक्स को हम लूप में चला देंगे जितने नंबर ऑफ जॉइंट्स होंगे. आर यू अंडरस्टैंडिंग गाइस?
Yes. Yes.
है ना? T0 से T1, T1 से T2, T2 से T3, 4, 5, 6 ऐसे करके we'll put those values, we'll get the transformation, we'll get, और सबको multiply करने का we'll get the direction cosines which we say the orientations and the positions also. Okay, okay. ये सब था कोड. ये सब वैल्यूज मैंने रखी इसके अंदर. ऐसे मैंने ऐसे ही रैंडमली कुछ भी वैल्यूज रखी. एंगल्स ऑब्वियसली मैंने यहाँ पे लिए हैं डिग्री टू मतलब रेडियन डिग्री में लिए हैं मैंने एंगल्स. यहाँ पे मैंने चेंज कर रखा है. और ये था हमारा वो Ti-1 to Ti वाला मैट्रिक्स. इसको फिर हमने लूप में चला के वी हैव मल्टीप्लाइड इट 5 टाइम्स. तो वहां से अपने को जो पोजीशन और ओरिएंटेशन मैट्रिक्स मिला. सो दिस इज टेलिंग अस द पोजीशन, दिस इज टेलिंग अस द ओरिएंटेशन. ओके. अब इसको जब हम 3D में प्लॉट करना चाहे, इफ यू वांट टू विजुअलाइज इट, तो आगे और कोड लिखना पड़ेगा. यू विल गेट द एग्जैक्ट. आप विजुअलाइज करके 3D में देख सकते हो व्हाट विल वेयर विल बी द आर्म विद रिस्पेक्ट टू द बेस. ऐसे करके guys, समझ आया सबको what is DH approach, what is DH parameters and how we use this matrix to transform. तो मतलब इन शॉर्ट कहने का मतलब मेरा ये है, आप किसी भी आर्म की पोजीशन DH पैरामीटर्स को यूज करके देख सकते हो. लेट्स से सपोज हमें एंड पोजीशन नहीं चाहिए, वी डोंट वांट द एंड इफेक्टर आल्सो पोजीशन. अपने को बीच में किसी का पोजीशन चाहिए, किसी आर्म का या किसी भी लिंक का पोजीशन चाहिए. तो वी वोंट गो टिल द एंड, हम बीच में ट्रांसफॉर्म करके 0 से 4 तक, 0 से 3 तक यूज करके विल गेट द पोजीशन. आर यू अंडरस्टैंडिंग गाइस व्हाट आई एम ट्राइंग टू से हियर?
Yes.
Okay, so this was about the this approach. So upon will use all this, it will be very useful. You will see this in every, you'll see this everywhere, this transformation. बहुत बहुत यूजफुल रहेगा while designing this rover. तो ये सब याद रखना, इस मैट्रिक्स को बस दिमाग में रखना कि ऐसा कुछ ट्रांसफॉर्मेशन मैट्रिक्स होता है. तो कभी कोड देख के घबराना हुआ तो व्हाट इज दिस ऑल अबाउट, तो ये सब है. तो आई थिंक सबको समझ आ गया होगा व्हाट आई मीन टू, व्हाट आई एम सेइंग हियर. ये रहा डीएच अप्रोच, दो जॉइंट्स के बीच में 4 पैरामीटर्स यूज होंगे, तो वो सब से हम निकाल सकते हैं. अब
So the
इन्हीं
DH
डीएच,
parameters are like, I'm sorry to interrupt, but the DH parameters are like already predefined.
या
Or
देखो अपन डीएच पैरामीटर्स को इनवर्स काइनेमेटिक्स में भी यूज करते हैं, फॉरवर्ड काइनेमेटिक्स में भी यूज कर सकते हैं. अब ये सिर्फ 4 पैरामीटर्स हैं, ये गिवन भी हो सकते हैं, ये गिवन में नहीं भी हो सकते हैं. गिवन किस केस में होंगे? दे विल बी गिवन इन केस ऑफ फॉरवर्ड काइनेमेटिक्स एंड वोंट बी गिवन इन केस ऑफ इनवर्स काइनेमेटिक्स. Okay, so this is the difference. Inverse kinematics, there is a different approach to calculate all this. We will get the different differential equations. So we'll get 12 differential equations for 12 different components. ये जो 12 components अपने को मिल रहे हैं ना, we'll get 12 different differential equations. So we'll find the solution of each differential equation to calculate the position, to calculate the what अपने को the angles between them, in short. ऐसा रहेगा. तो that is a different approach. वो भी explain करेंगे, but my part is done. अब कोई doubt हो तो बताओ यार इसके अंदर, तो then I'll hand it to the यश आगे. Any doubts guys?
no, not really.
समझ आ रहे हैं ना सब? पर आराम से चिल होके पूछा करो, कोई सीन नहीं है भाई, कोई कुछ नहीं है. इफ यू हैव कोई भी छोटे से छोटा डाउट हो, यू आस्क. ठीक है? वेरी इजी. वी यूजुअली आस्क वेरी इडियोटिक क्वेश्चंस इन आवर टीम. पता है, ऐसे ऐसे क्वेश्चंस पूछते हैं, बहुत बेकार बेकार क्वेश्चंस पूछते हैं. सो यू आर ओपन टू आस्क एनी काइंड ऑफ क्वेश्चंस. ठीक है, चिल है. ओके, सो जस्ट या आर यू हियर?
Yeah. So hi everyone. I'll be taking forward with this, but then I'll be teaching only the simulation part on ROS. So how many people have worked with ROS up to now? Okay, who all have not worked up, just speak up. Okay. So
This is
I'll be
all for
sending
learning
the
guys. This is all for learning guys. तुम्हें आता है तो बताओ, नहीं आता है तो बताओ. Be very frank with us, okay? All are here for learning, okay? So I'll mute here. Just carry on. Right.
Okay, so I'll be sending some documentations or tutorials of ROS, so go through that. Today I'll be just doing like a normal simulation work, which you can like look up in the recording and ask any doubts if you all have. So okay, can you all see my screen?
Yeah.
Okay. So we'll be like first going forward with what is a okay, how many of you all know what are STL files?
Just could you repeat what he said?
How many of you all know what are STL files? .stl. Like, do you all know about this file? Okay, so .stl files are basically the 3D model files which you create or you render in any CAD software. Okay, so from those STL files, you can create Zacro files, .xacro. So those files, they like convert the STL files into coordinate systems. So like they tell what are the coordinates of the arms, what are the coordinates of everything. And from those Zacro files or URDF files, like both are acceptable, you can create configurations and then you can simulate the robot. Okay, are you all with me so far?
Yeah.
Yes.
Okay. So you can see that this is a configuration which I showed yesterday. So like I'll be sharing the documentation on this, like how to get the ROS entire system working, and then how can you like get these 3D files and start working with this. So yeah, this is like the I showed this demonstration yesterday. You can see it up on the recording. Yeah, so okay, so this is a command to open the setup assistant. Okay, it's over here. Okay, so it's ROS2 launch and then move it setup assistant setup underscore assistant or launch.py. So this is the package, move it setup assistant, and this is the launch file, Python launch file. Okay. Yeah. So then it opens such a package like this. So this makes your life very easy in inverse kinematics. So instead of programming each and every transformation matrix, this creates the entire configuration for you. So let's go with new package. So here you can load a URDF file or Zacro arguments. So I have a URDF file. I'll be sharing this file, like I've already shared this file to you all before, like in the TRS meets also. So you all can share it amongst yourselves if you all don't have it. So URDF, and this is my like robotic arm Ferrino 3 version 6 dot URDF. And once you load it, then it like okay, so now it tells you now you can work with this. Now, uh, what does self collision mean? So self collision means that if you program the angles at such high values or such low values that the robot collides with itself. So you can see that there might be an instance where the end effector, the wrist, collides with this arm. Like if you bend this joint too much, so it can collide with itself. So you always keep the sampling density high so it can like test out each and every case you want, generate the collision matrix. So this creates that whatever scenarios it can hit. So like reason to disable adjacent links, this is never in. So this shows that link A, base link and upper arm, this part doesn't get collide, never collides. So like all of the possible scenarios it has tested and it gives you this matrix. Then virtual joints is like you can create the joint whichever you want. So let's say joints, uh, then base link, and you want this to be fixed. And parent frame name you can say world. So I want like here my base is fixed. If I don't have a base fixed, then I can like change this to a floating or a planar base. So planar is usually used if you're like moving in 2D, and I'm using fixed only for now. Then planning groups, you can add groups. Let's say arms. Kinematic solvers are like basically A star or RRT star, whichever you want. So we go with SRV, and then here in default planner you choose RRT, RRT star, then yeah, there I think removed A star. So we choose RRT star. So basically RRT star does is like you all have done this in CV. Have you all tried this in CV, computer vision?
Yes.
So it's basically a path planning algorithm. So this like plans out all the stuff. So you basically add the joints over there. Like recommended to add joints. So you choose all the joints, you add them. Yeah. So then these joints are now defined into the planning group. So whatever end effector location you want, the planning group is going to affect all these joints. Then robotic poses is like the normal base pose you want. So I'll call this as home, where everything is zero, and I'll set this as and create a new one as default. So I can like change the orientation of all these things and call it like this is my default pose. If there is any problem, I can revert back to this pose. With me so far? Like this software is mainly used to make your life in inverse kinematics easy. Okay, what about everyone else? I just got thumbs up from Pratik, I think. Okay.
Just one question.
Yeah.
Where am I using the path planning algorithm here?
You're using the path planning algorithm in the planning groups. So like if you move the end effectors, like here you define your end effector and wherever the end effector's location is there, you plan it accordingly and then you can I'll show. Yeah, so you can see this robot, right? Now if let's say I
Yeah.
move this to this orientation, can you see the difference? Like what is the initial state and what I'm asking it to go to? So if I
Yeah.
say plan, so then this movement that is controlled by RT star. So the trajectory of the end effector is controlled by RT star.
Oh, okay. Makes sense. Makes sense. And
So it goes for the shortest location. I'm not sure on how RT star works and what is the difference between the planning algorithms, but yeah, like those are just used to make your life easier. The movement of the end effectors for like trajectory.
Yeah, I would like
makes
to add something here. What happens is these are the path planning algorithms. What we do here is if you want to go from one place to another place, let's say you know what is the difference between distance and what is the difference between distance and displacement, guys. SAE we have RRT and RRT star. RRT star does is it gives us the optimal path, like the shortest path it can go, it can take. So it will find the shortest path to move from one place to another place, and that is what RRT star does is. There can be thousands of ways it can go, so it will take the shortest one to move from there. Okay, that is the difference. Okay, so it will reject out all the other paths. It will take the shortest one. This is RRT star does. Okay, that is fine. If you want, I have one more. After completion of this, I can demonstrate you the that live usage of RRT star. We'll discuss that also. Add to that.
I had one more doubt actually. So, like I'm like planning my path from one point to another. But if I am using inverse kinematics, I'm starting off at one position and I now know how much every angle needs to be rotated, every like joint has to be rotated or something to reach a final position using inverse kinematics. So then why do I need a like planning algorithm? Why can I not just use the like the parameters that I got from inverse kinematics?
Becomes too complex to calculate all of the transformation matrices.
Okay.
And planning algorithm makes your life more optimized.
Yeah, in that
Not rushing.
I told you na yaar ki in inverse kinematics अपना transformation matrix what final results we'll get it in the form of differential equations. So getting the solutions of every differential equation is very tough. So what we do, we take the simple minimalistic cases. So that is a good option to actually go for. So handling the differential equation is one kind of thing. So we'll add it with the so RRT star is a good way to make it actually easy. Path algorithms actually make it easy to solve differential equations. I think.
Oh, I didn't understand why will it be in inverse? How do we get differential equations exactly? Like,
यार उसके लिए तो मुझे थ्योरी पढ़ाना पड़ेगा. I
oh,
can
okay,
teach you
okay.
the theory. I can take one more lecture. Yeah, inverse kinematics अभी नहीं पढ़ाया. I'll teach you the inverse kinematics. You'll get to know the differential how those are coming. Yeah, we'll discuss that. Discuss that. I'll add to that. Discuss that also. अभी ये समझो आप. We'll discuss that also.
Okay, any more doubts? Yes. Okay. Moving on then. So end effectors is basically what your arm should be like moving, what it takes. Like if you want to perform a certain operation, you want the robotic arm to reach at a certain point, you give the reference of the end effector. So you say like gripper, you can give it whatever name you want. Then the group is only arms because you have only made one planning group. So if you have a robotic arm attached to another robotic arm, then you can use two planning groups. Then the parent link, so you want it to be the wrist. So you want the wrist linkage to be the link given to the end effector. And parent group, you say arm. So it should be like located to arm. So if you have got a robotic arm attached to another robotic arm, the parent group of this end effector would be the second robotic arm. If you're getting my point. You save this. Passive joints are the joints that basically don't do any work. So like they are dependent on the other joints. So if you've got like two, if you've seen in the yesterday's PPTs, so there were these joints which are dependent on the other person's joint, like other person's movements. So then those are passive joints. Here, which we don't have these. So each and every joint is actuated. So each and every joint is independently controlled and like they have their own servo motors. So we don't have any passive joints here. Then the ROS to control URDF modification. So what this does is it tells you what interfaces you want. So if you want to see the output of the robotic arm, like the position. So if you want the position, the velocity, or the effort. So the end effectors, if you want, is position. Like basically, we play around with position only. We assume that the effort required is very less and the velocity required is very less. You just want to change the position of the end effector because you don't care about the velocity or the effort until and unless you go into the real physical models. So you choose command interfaces as position. So you basically want to only give the position as a command to the robotic arm. And position and velocity, so this is used in simulations so that position is used basically so it doesn't collide with itself or any other objects you put in the environment, and velocity so it doesn't exceed the velocity of the servo motors. You don't like put effort because effort of servo motors are usually hard to calculate. So yeah, like these are just a normal default. You can choose to add effort if you want, and then these interfaces they give you the output on your uh, terminal. So they like show on this terminal they show you that how much effort is being put in this movement or how much what is the position this travels on. So ROS2 controllers. So controllers you are like joint trajectory controller. So this yeah, so this movement is being controlled by this planning algorithm. So the planning algorithm tells what its trajectory should be. The control algorithm control code it shows the robot how to move. So like basically you just auto add your joint trajectory control algorithm for planning group. So if you have got again two robotic arms and you have different planning groups. So this is your ROS2 controller. So you can control it using ROS2. Now, so ROS2 means you can basically control it using your terminal. Then you've got move it controller. So there's a library in Python called move it. Now for ROS Humble, which I'm using and which you all will also be using, there is move it 2.0. So y'all have to study that after later on. So this helps you control the robotic arm using your Python code. So you can extract data like coordinates from an Excel sheet into a Python code, feed those coordinates of the end effector to the ROS2 code, to the move it controller. So you can like make an entire trajectory of how it should follow and where it should like stay for a long time. So you can load the robotic arm and remove the load robotic arm. Basically hard coding for now. Then once you introduce perception and AI onto this, then you don't need to hard code the trajectory using Excel. Are you getting my point up till now?
Yes.
You can see down, guys. What are you so ashamed of? I mean, shy of or something. You're all are from TRS only. I'm your TRS senior. Why are you so shy now? 1 year has passed on.
That's why I was saying to unmute. सबको unmute करो. Hello, Rupesh, Siddhant, Sujar,
Yes.
Pratik, guys.
Like
Yeah.
no one is forcing you to like join this meet, so you all can say whatever you want whenever you.
Ask the doubt, whichever doubt you have. See, I have shared something in the chat box. एक छोटा सा image I have shared. RRT star path planning, avoiding the obstacles, ऐसे करके. So that this gives the optimal path ऐसे करके, which he was explaining. एक जगह से दूसरी जगह जाना हो with the shortest path, stylish path planning everything. Just keep on asking
Okay,
questions from the people, random people ऐसे ही करके. So they'll open up. एक दो दिन में they'll open up. They'll open.
is there any non-TRS person here? अच्छा नहीं है भाई अभी तो बोल दो क्या शर्माना
Yeah, it's
your
it's more
doubts
sort
won't
of
be
that.
stupid.
It's more sort of that. Like I haven't used it, so like uh, I am getting what you're saying, but given the fact that I haven't used it, so I'm not getting like sort of hang of it. Like I'm understanding what you're saying,
Okay.
but only after I do that once will I be able.
Yeah, same
You're
over.
talking
Yeah,
about
makes sense.
the software, but it doesn't
Yes,
work on Mac.
yes,
As per the
exactly.
project.
Okay, by the way,
Who are the
well,
math people here?
I linkage also
Oh,
doesn't
oh,
work.
yeah, sad life.
the Mac people, you guys can install Ubuntu Linux. एक छोटा सा like for 50 GB एक partial बना सकते हो अपना.
Okay.
मतलब anyways you would have to start with ROS. और Mac हो या Windows हो, that can be possible. बस हर जगह होना चाहिए लैपटॉप में. And for people की ये लग रहा है कि ये सब चीज कहाँ से आ गया. This is mechanical training right now. जब तुम लोग सॉफ्टवेयर जाओगे, परसेप्शन में जाओगे, इवन कंट्रोल्स, एम्बेडेड कंट्रोल्स में जाओगे, यू वुड सी इन मोर डिटेल कि ये सब चीज क्या हो रहा है, कैसे होगा. वहाँ पे एकदम अच्छे से तुम लोग को रॉस पैकेजेस के बारे में बता दिया जाएगा.
सब चमकेगा दिमाग पे, पता है, सब चमकेगा। एक बार जब तुम हैंड्स ऑन करने लगोगे ना, तो you'll also generate new ideas. You guys are only going to be the ones who are going to design this world. ठीक है, सब चमकेगा, बस keep with us. तो राठौर है, simple है।
Just one point of doubt. Is the like the rover has been separately designed by now, right? Like we are being given tutorials after that, or will it happen after this? Like, is there a separate project, as in where the actual thing is going on? And
अभी
नहीं, अभी तक if you would, yeah, हितेश कंटिन्यू.
नहीं प्रणव, बोलो बोलो।
अरे टिल नाउ तुम लोग का ट्यूटोरियल्स सब मैनेज करने में ही हम लोग को मोस्ट टाइम लग रहा है. यस वी हैव प्लान्ड अ फ्यू थिंग्स, बट दोज आर नॉट डिजाइन्ड बाय अस ऑन एनी सॉफ्टवेयर. वी आर जस्ट प्लॉटिंग की हाउ would we design, what will be the most optimal way and all those things. For example, एक छोटा एग्जांपल देता हूँ आर्म के लिए. would it be 5 degree of freedom, 6 degree of freedom, or even 7 degree of freedom? वो सब चीजें आज ही हम लोग बात करते हैं. मी एंड जश वी आर टॉकिंग अबाउट दैट. फिर जब रोवर सस्पेंशन का बात आता है, मी एंड तंत्रेश एंड विश्वजीत वी आर थिंकिंग अबाउट दोज पार्ट्स. तो अभी दिस ऑल ऑफ दिस व्हाइल यू आर गेटिंग टॉट बाय अस, हम लोग यहाँ पे डिजाइन फाइनलाइज कर रहे हैं. वंस तुम लोग का मेंटरिंग सेशन खत्म होगा, एट द सेम टाइम आर डिजाइन आइडियाज विल बी कंफर्म. उसके बाद साथ में बैठ के ही वी वुड बी डिजाइनिंग इट ऑन कैड. वहां से फिर रॉस, रॉस से फिर सॉफ्टवेयर जीयूआई, सब चीज साथ में होने वाला है.
yeah, okay.
You guys will be doing all the work. हम सब मिलके सारा काम करेंगे. इट इज जस्ट कि तुम्हें आइडिया लग जाए हाउ द थिंग्स विल वर्क, कौन कौन से सॉफ्टवेयर यूज होने वाले हैं, सब हम बैठ के ही बनाएंगे. इट्स लाइक यू आर ट्रेनिंग योर आर्मी टू फाइट द बैटल. अनलेस यू आर नॉट ट्रेन्ड, हाउ विल यू फायर द गन? मस्त लाइन बोल रही है, हाँ सर, सही है.
Um, I just wanted to ask a small doubt. I know it's a little too far ahead into the future, but like, how are you guys going about PCB design and like the this thing? Are you guys going to custom design it, or will you guys order it from like external sources? Or yeah, I just wanted to know that.
Okay, so the embedded team, right?
Yeah.
Right now, if I give you a small hint, we are looking into different type of microchips for now. PCB designing normally takes around, we expect it to be around a 8-hour thing. But if we distribute that into 4 days, it takes a lot of time. We are thinking ki how to optimize that. Agar, if possible,
ट्रेनिंग में हो पाएगा तो वी वुड ऐड दैट, इफ नॉट एक बार ट्रेनिंग एंड हो जाएगा, आफ्टर दैट जब चैसिस सिस्टम हम लोग बनाते रहेंगे, अलॉन्ग दैट हम लोग साथ में सिखा देंगे फॉर दोस हु आर इंटरेस्टेड। अभी चल रहा है, अभी चल रहा है, लाइक कस्टम पीसीबी विल बी देयर, बट द पार्ट की आर वी गोइंग टू टीच दैट टू एवरीबॉडी और सम स्पेसिफिक स्टूडेंट्स, वो भी कंसर्न है।
Thank you. I just want to know that.
अच्छा बाय द वे, जश हो गया क्या तुम्हारे साइड से?
नहीं नहीं, अभी लाइक थोड़ा ही बाकी है.
ऑल राइट, श्योर, यू कैन
Okay.
कंटिन्यू दिस।
Yeah, so
किसी और को
moving
कोई
on.
डाउट?
Guys, कोई भी
क्या
डाउट हो
ठीक?
तो बता देना. Okay, fine, moving on. So perception. So this is where you just add your 3D sensors. So you can use LiDAR and like the plugins you want to configure. So you can add your LiDAR configuration and everything over here. I don't have any for now. So this is used to make your robot autonomous. Then launch files. So whatever you want in your launch files to have. Basically, you take on everything because you don't know when you want. Then configuration info, author information. So like this is just for copyright purposes, I feel. I'm not sure about why author information is required. But then yeah, you add your name. You won't get emails from Move It, but you just like add it over here. And configuration file. So you choose where you want it to be saved. Like so I can save it over here. Like this is already existing of mine. So I don't need to create another. But yeah, you can create your own configuration file and generate package and then you exit cleanly. So let's just exit. And now you can see that this code which I've used over here. Yeah, this code ROS 2 launch Perino 3 version 6 move it config demo.launch.py. So this I'm accessing the launch file and I'm using the demo launch file from there. I'm accessing the config which I've already created and the demo launch file and then creating the simulation. So this is just for demonstration purposes. You can create whatever launch file you want. So
Just if it's possible, could you send the launch file just so that I can just try it out once?
do you have all the like specifications required for the launch file?
Not sure. I have ROS2 installed. Um,
Yeah, but you'll need the Zacro file and everything. I'll share I've already shared the GitHub repo with you. You can
oh,
just clone it and follow the steps over there.
all right, okay. Thank you.
Yeah, so you can see that there are so many launch files over here. So setup assistant.launch, which I was using to create the thing. So this just gives me a like if I use this inside this now, if I launch this file, so it will just give me the option to edit. Then there is demo launch. I can create my own launch file over here, which was this warehouse db.launch file. Yeah, so you can see that move it RBase also is created over here. So do you all have any doubts regarding this?
Josh, when you make the CAD design, do you have to specify where the joints will be in the CAD itself?
So no CAD design. So one just I don't have the STL file opener over here. Then uh, let's see if I can show it to you. So inside meshes, I've got my STL files over here, which which like someone has designed from CAD. Then in my URDF file,
So you can see URDF file is just a code version. So it takes the STL file, it takes the mesh, the geometry. Okay, it gives it the material. So you can like choose which color you want it to be in. So like this was default set to gray. You can choose its inertia values. You can like make it more heavier, the mass, and you can set its origin coordinates. So of that link, like the base link, what is the origin? Here is not perfectly zero. You can't get also perfect zero. You'll always have some error. So basically, you can create a URDF. Like this URDF file was automatically created. So you don't have to type out everything over here. So once you create an STL file, you once you create like all of these meshes inside the STL file, like you have all of these meshes. So you've got base, forearm, shoulder. You can create a gripper also. You can create a screw which is attached to the wrist three, whatever you want. And then from this, you can like automatically create a URDF file. So you don't have to type all of this out. Like obviously you can't type it also. So it's just automatically created.
अभी इस चीज का like to be honestly you don't have to take it so deep. Once like the first 3 days were designed in a way कि theory तुम लोग समझ लो, then you will start from like hands on CAD design होंगे. Once you will complete everything on CAD, फिर उनको analysis कर लेंगे materialistic view में, then we can फिर जाकर the material. Yep. uh, was I disconnected for a second?
Yes.
Okay. uh, so I was saying कि first you will make everything on CAD. ठीक है, जब तक CAD करते रहोगे you don't have to think about URDF and all. ना URDF सोचना, ना 3D प्रिंटर सोचना, कुछ नहीं, बस CAD कर रहे हैं बैठ के. एक बार CAD आराम से बना लिए, परफेक्ट कर लिए, ऑल द पैरामीटर्स आर गुड, सारे स्क्रू होल्स देख रहे हो कि हाँ ठीक से काम कर रहे हैं और फिर जाकर हम लोग उसको ट्रांसफर करते हैं ऑन URDF. जब URDF में ट्रांसफर कर लेंगे, देखना तुम ऑटोमेटिकली हम लोग वो थर्ड पार्टी से होता है, तो बस 2-4 बटन दबाओगे, ओके कंफर्म ये सब, then automatically URDF will be generated and URDF generate हो जाएगा, STL generate हो जाएगा, then you will come to ROS move it और यहाँ पे फिर वो सेम STL फाइल अपलोड करोगे. You won't find that much complicated. इसलिए what is suggested कि इतना दूर का मत सोचो, ठीक है. Although we are like बहुत अच्छे से देखने के लिए the best thing is कि you see everything on first hand कि कैसे कर रहा है, और जस्ट जो पूरा बनाया हुआ है ये showing you कि कैसे सब कुछ होता है फाइनली. बट एट द सेम टाइम इस चीज का भी टेंशन नहीं लेना चाहिए कि सब कुछ मैं कैसे बनाऊंगा. यू गाइस गेट द पॉइंट. आज फर्स्ट डे देख रहे हो, आई एम नॉट एक्सपेक्टिंग कि ज्यादा लोग ऐसे जेन्युइन डाउट्स पूछेंगे कि एग्जैक्टली क्या क्या लिखा है, नॉल तुमको खुद समझ नहीं आएगा. बट वंस यू विल रीच टू दैट पॉइंट, तब सही में अच्छे डाउट्स आएंगे, तुम लोग खुद फील करोगे कि हाँ ये तो मेरे से बन रहा है, राइट.
Yes.
सो इफ यू आर थिंकिंग.
Also, I have a doubt. Like with Move It, can we move any simulation, like any URDF file that we create, or like we'll have to use the like default that just was showing just before?
Nope, nope. Everything you can. First you have to create like just ये default था रोबोटिक आर्म की, वो भी तुमने इनपुट किया है.
What do you mean by default? मैंने रोबोट काम भी GitHub repo से लिया, मैंने create नहीं किया सॉलिड वर्क्स.
मतलब यू कैन पुट एनीथिंग. काफी जो लेगेड बॉट्स होते हैं, दोज आर आल्सो एनालाइज्ड बाय मूविट. तुम अच्छे से देखोगे उसके बारे में, यूट्यूब में भी सर्च करोगे.
Okay.
ओके एनीवेज हाँ. Just continue.
हो गया
ठीक है तब तो yeah. Did you guys install linkages?
No, it
Linkage
was
is not available on Linux. Is there any workaround?
Windows पे भी हो जाता है. Either you can install it on Windows or Linux.
Like, is there a Ubuntu alternative?
Yeah, so you can add virtual.
Okay.
वर्चुअल मशीन से के साथ काम किया कभी?
नहीं, लाइक पता है वर्चुअल मशीन ऐसे देखा हूँ पर खुद से कभी नहीं किया.
That would be great. Otherwise, I'm not sure कि
नहीं, ओके
first
ओके
hand कभी.
डुअल बूट भी मेरा डुअल बूट है पर मैं अभी बहुत समय से विंडोज चला नहीं रहा था तो इसीलिए.
All right. तब तो कोई इश्यू नहीं है मुझे. Anyways, about linkages, have how many of you have used that software? Winter school में there was linkages, if I'm not wrong.
Yes.
Okay. 3 hands. क्या बनाया था उसमें? Hello.
Yeah, we made a
in-
quadruple bot using linkages, using a single actuator.
So that one we saw कल
Yeah,
शायद.
yesterday.
Okay. Did you guys understand that या फिर बस देखे और बना दिए?
Now there was a we were also taught a rule that the summation should be something less than sum. According to that, it was
Okay.
working.
What was the name of that principle?
I don't remember that.
Just क्या वो slides दिखा सकते हो? You
It's
have
not
that slide on
Grasshop's law, no?
Ubuntu.
Grasshoppers.
Grasshopper. उसमें क्या था? What was that?
S plus
जैसे
L
वो
less
setup
than
करना.
P by Q.
What? Repeat.
S plus L less than P plus Q.
What is
Right.
SLPQ?
The sides of the quadrilateral. Yeah, and S
Okay.
and L were mostly they were adjacent.
Okay. Adjacent था कि shortest plus longest था
Oh,
वैसा था.
sorry. हाँ, shortest plus longest. Sorry.
Yep.
उसमें specifically ऐसे है. हाँ.
The example had that कि adjacent में.
Yes.
Universally,
Yes.
that is not true.
Yes.
ठीक है. So, okay. I'm not sure कि how I'll show that. I'm on my phone right now. Yep. This was the Grasshoppers law, right? So, कौन how many of you like actually made this linkage to try? Not the quadruped, but yeah. Okay. ठीक है. Do you know like okay, linkages mechanism is a bit complicated. कुछ already standard mechanisms बने हुए हैं. But then how everything started? Like how do you understand कि how the linkage is working and all? Did you get that thing? कभी ये आया क्रिएटिविटी की भाई इतना कॉम्प्लिकेटेड चीज सोचा कैसे होगा बंदे ने?
Anyone? Am I audible? Okay. यार कुछ बताओ यार, ऐसे हम सब करके
और लाइक मतलब सोचा कैसे वो ये एग्जैक्टली कैसे मतलब ऐसे डिटरमाइन कर सकते हैं कि
ओके
मतलब
ओके
कोई भी मतलब फर्स्ट ये वाला जैसे मतलब कोई बहुत बेसिक मैकेनिज्म पकड़ा हुआ है लाइक ये वाला जैसे कोई फोर मतलब कोई क्वाड्रिलेटरल कोई ऐसा जिसमें सारी जॉइंट्स अटैच्ड हैं और मतलब एक्सटेंडेबल है द लेंथ कैन बी चेंज फॉर द जॉइंट्स सो देन once you get the idea of a quadruped then it sort of generalizes कि बाकी में भी कैसे होना चाहिए तो
okay.
वैसे दिख लगता है
So let me show you something. Have you anyone of you heard about lambda mechanism? लैम्बडा मैकेनिज्म के बारे में कोई जानता है? यस नो, नहीं भी पता होगा तो कोई बात नहीं है, अच्छा नो बताओ।
नहीं
No.
No, no.
ठीक है रुको, तुम लोग को दिखाता हूँ। जस्ट 1 सेकेंड। यप, is my screen visible right now?
Yeah.
Okay, so this is another quad. The one you saw had only one actuator. This one has two actuators. पर इन सब के बेसिक में क्या आता है? Let me show you that. This is what we call lambda mechanism. ठीक है? Why it is called so? क्योंकि lambda जैसा दिख रहा है। ठीक है? The smallest mechanism which you can design is a like four-sided quadruped जो movable हो, मतलब four-sided this mechanism जिसमें एक तो ग्राउंड लेंथ होता है, ग्राउंड लिंक होता है which we normally avoid, बनाते नहीं है। After that there is one actuator, ये वाला लिंक रोटेट करेगा and because of the rotation of this link बाकी सब पार्ट्स रोटेट करते हैं, right? So once we rotate this linkage you'll see कि रुको एक सीधा वीडियो ही दिखाता हूँ तुमको। Let me show you this, तब तक थोड़ा सा मन बहकेगा। ये थोड़ा सा कॉम्प्लिकेटेड होगा। Let me show you this one. This mechanism is called paradoxical mechanism. इसमें ध्यान देना, this part is where we rotate by hand, ठीक है? इसमें मैनुअली रोटेट करना पड़ता है। You'll find out कि clockwise अगर रोटेट करोगे then the wheel will turn in a different on a different speed, और जब एंटी क्लॉकवाइज टर्न करोगे तो एक डिफरेंट स्पीड पे टर्न करता है। ठीक है, एक बार ये देखो, there is no sound in this by the way. तो दिस इज द लैम्डा मैकेनिज्म जहाँ से सब चीज स्टार्ट होता है। ठीक है, इफ यू चेंज द लेंथ ऑफ द लिंकेजेस ये डिजाइन चेंज हो जाता है, द पाथ विच इज टेकिंग प्लेस एंड हाउ वी ब्रेक डाउन दैट पाथ वो यहाँ पे दिखा रहा है बाय टू सर्कल्स। ऑब्जर्व करना है इसको क्या हो रहा है। ओके, डिड यू गाइस ऑब्जर्व कि उसने जब क्लॉकवाइज रोटेट किया और एंटी क्लॉकवाइज रोटेट किया, कितने नंबर ऑफ टर्न्स लगे?
Yes, एक बार there were 2 turns and another time there were 4 turns.
यप। सो ये भी एक मैकेनिज्म है, देयर आर डिफरेंट टाइप्स ऑफ मैकेनिज्म। ये सब तब के टाइम के हैं व्हेन एक फर्स्ट टाइम मैकेनिकल एंड मैकेनिज्म वो सब चीज़ के बारे में बात हो रहा था। ठीक है? तो जैसे तुम लोगों ने देखा था विंटर स्कूल के टाइम पे एक क्वाड्रूपेड, वैसे ही एक और यहाँ पे मैंने स्टार्टिंग में दिखाया था ये वाला। तो ये सब चीज़ कॉम्प्लिकेटेड चीज़ें कहाँ से स्टार्ट होती है? मोस्ट ऑफ द टाइम दे स्टार्ट फ्रॉम द लैम्बडा मैकेनिज्म। अब इसमें हर एक चेंज करोगे लेंथ तो शेप चेंज होता है। दैट इज़ मोर लाइक हिट एंड ट्रायल करते जाओ। कुछ सब लोग स्टैंडर्ड फाइंड आउट कर चुके हैं, कुछ सब चीज़ें अभी भी पता चलती है तो ठीक है। इवन द लोगो व्हिच यू कैन सी, जो वेबसाइट का लोगो है, कैन यू गाइस सी कि उसने एक सिंगल रोटेटरी एक्चुएटर से एक लीनियर मोशन क्रिएट किया है, अप्रॉक्सीमेट लीनियर लोकेशन मोशन दिख रहा है?
Yes.
Yes.
ये वही है, रुको। तो ये सब लिंकेजेस जो नॉर्मली होते हैं, ठीक है, ये एग्जिस्ट तो करता है, बट वेयर आर वी यूजिंग दीज थिंग्स? इसके बारे में एक बार बताता हूँ, एक बार ये देख लो। वी आर चेंजिंग द लेंथ ऑफ द लिंक, बार बार हिट एंड ट्रायल एंड टेस्ट कर रहे हैं। यू कैन सी कि वो ज़्यादा ट्रू लाइन की तरफ टर्न हो रहा है, बट देन द कंस्ट्रेन इज ऑल्सो इंक्रीजिंग, लेंथ छोटा होते जा रहा है स्ट्रेट लाइन का। तो ये वाला ज़्यादा इंपॉर्टेंट था, स्ट्रेट लाइन वाला, फॉर अस इन द स्पेसिफिक सिचुएशन। व्हाई आई एम टेलिंग यू दिस थिंग इज बिकॉज, तो ये दिखाता हूँ। डिड यू गाइस सी जो डे 0 पे मैंने बोला था, गो एंड चेक आउट अदर पीपल डिजाइंस ऑन रोबोटिक्स ऑन देयर ओन रोवर्स?
Yes.
किसी ने ये एड शास्त्र का देखा?
इसका वापस एक
क्या? एड शास्त्र,
कौन
आज शास्त्र, पता नहीं हाउ दे say this, ये वाला। Did anyone of you go and check out their design? ये वाला लिंक है। कोई देखा ये?
No.
ओके, एक बार मैं दिखाता हूँ व्हाई आई एम टॉकिंग अबाउट linkages. So D1 में you guys understood कि there are type of actuators, hydraulic actuator होते हैं, electronic actuator होते हैं, right? Which type of actuator are they using in their robotic arm? कोई भी बताओ यार।
It looks hydraulic.
Yeah, it's a hydraulic.
Pneumatic in बोलते हैं, but yeah, this is pneumatic actuators. Pneumatic actuators का क्या disadvantage होता है बताओ तो एक बार, advantage और disadvantage।
Yeah, they work
Advantage
on
ये
air
कि
pressure, ना?
एक एक करके, एक एडवांटेज बताओ, दूसरा डिसएडवांटेज बताओ।
एडवांटेज कुड बी कि लाइक काफी ज्यादा लोड, मतलब अगर आप इलेक्ट्रिकली ये करें तो फिर उसमें उतना लोड उठाना पाए, बट न्यूमेटिक हाइड्रोलिक जब होता है तो फिर इट कैन लाइक इट डजंट गेट अफेक्टेड बाय मच लोड।
ओके, डिसएडवांटेज कोई और बताओ।
Yeah, air is generally compressible, so it may not be that accurate.
ओके, एक्यूरेसी एक पॉइंट है, एक और पॉइंट है, एक्यूरेसी एक अच्छा पॉइंट है ऑल्दो।
Wear and tear of the system is more because of the moving piston.
रिपीट क्या बोला?
Could it be that the wear and tear of the systems is more because you have to deal with these fluids?
Wear and tear is more dependent upon the gear design, पर हाँ इसमें लाइक इफ यू सी लॉजिकली तो इसमें ज़्यादा गियर्स होते हैं, तो इट कैन क्रिएट मोर वेयर एंड टेयर। आई एम लुकिंग फॉर समथिंग एल्स, कुछ लिंकेजेस से कनेक्टेड मैं पूछना चाह रहा हूँ। एनीवन एल्स वांट्स टू ट्राई, या फिर मैं सीधा बताऊँ? ओके, एक बार कैन यू टेल मी कि व्हाट इज द मैक्सिमम हाइट द आर्म कैन रीच? एक तो थियोरेटिकली इफ यू रिमूव द न्यूमेटिक एक्चुएटर्स, तब कितना ऊपर जाएगा, एकदम स्ट्रेट लाइन बन जाएगा, झंडा बन जाएगा, राइट, स्ट्रेट पोल हो जाएगा।
यस,
But now because of the pneumatic actuators, how what is the maximum reachability of the robotic arm? थोड़ा कम होगा,
यस,
Yes.
तो reachability कम हो रही है।
Yeah.
So why we use linkages? एक robotic arm concerned मैं बता दे रहा हूँ कि the constraint of the distance same actuator है, ठीक है, अगर वो लोग कहीं और लगा दे, फॉर एग्जाम्पल लेट मी शो यू अनदर वन। ओके, एक सेकेंड देना। लेट मी शो यू कौन सा, या एमआरएम को दिखाता हूँ। ओके, इनके एक्चुएटर्स का डिजाइन देखना, दे आर आल्सो यूजिंग एक्चुएटर्स, राइट?
Yes.
एक्चुएटर्स है, एक ये है, एक ये है, दे आर यूजिंग देयर ओन डिजाइन ऑफ एक्चुएटर्स। सो यू कैन यूज डिफरेंट एक्चुएटर का डिजाइन but which one will give you more accuracy and which one will constrain you from reaching different distances, ये काफी important होता है. And also about while we think about linkages, we also see कि if we are if our active actuator is rotating या linearly moving at a uniform speed, the end effector is not like uniform with the speed of the actuator itself. इवन अगर इसमें देखोगे जो मैंने पहले एग्जांपल दिखाया स्ट्रेट लाइन वाला, यप, इसमें इफ यू गाइस कैन फील कि यहाँ पे एंड पे स्लो हो जा रहा है बट देन बीच में फास्ट हो जा रहा है, तो द स्पीड इज आल्सो नॉट यूनिफॉर्म इनफ. ठीक है, तो
Yes.
थिंकिंग अबाउट ऑल दीज थिंग्स, ये सब चीज आते हैं लिंकेजेस में. यहाँ पे हम लोग को लिंकेज सॉफ्टवेयर का यूज करना होता है, राइट. नाउ हाउ टू यूज लिंकेज सॉफ्टवेयर, मैं ज़्यादा इसको बोरिंग नहीं करना चाहता हूँ कि मोस्ट ऑफ टाइम इट बिकम्स वेरी बोरिंग. यू गाइस हैव नॉट सीन मी ऑन विंटर स्कूल, बट जस्ट वाले जब बैच को मैं समझा रहा था, इट टुक मी around 10 to 15 hit and trials to work the lambda mechanism itself. So I won't take that thing. सीधा मैं तुम लोग को दिखाता हूँ कुछ लोगों का YouTube पे who works on this. Let me see. So yeah, मैं ये इन लोग का एक बार देखना linkage design, how actually we decide कि what is the length. कुछ सब typical lambda mechanisms होते हैं which we have already seen कि straight line कैसे बनता है. फिर जाकर इससे पहले वाला जो मैंने दिखाया कि अगर there is a robot which is walking, तो walk cycle normally ऐसे ही दिखता है. अगर किसी ने quadruped bots वगैरह के walk cycle पे ध्यान दिया या फिर even human walking cycle, you keep your leg थ्रॉट लाइक एक स्ट्रेट लाइन में एंड देन यू लिफ्ट योर लेग जो ऐसे आर्क डिजाइन करता है. दैट इज हाउ अ जनरल वॉकिंग साइकिल लुक्स लाइक. वॉकिंग साइकिल के लिए ये लैम्डा मैकेनिज्म यूज होता है. तो इवन ये वाला अगर तुम देखोगे इसमें, लेट मी शो यू फ्रॉम हियर ऑनवर्ड्स. यहाँ पे एक लैम्डा मैकेनिज्म है, दिस इज वन लैम्डा, एंड उससे बस एक ड्रॉप डाउन कर दिया गया है एक लेग को, तो वहाँ पे वॉकिंग साइकिल काम करे. तो डिफरेंट लैम्डा मैकेनिज्म्स होते हैं जो स्टैंडर्ड लैम्डा मैकेनिज्म्स होते हैं. तो फॉर डिजाइनिंग दोज थिंग्स हम लोग को लिंकेज का जरूरत पड़ेगा, राइट. इवन इफ यू विल सी द सस्पेंशन सिस्टम, एक और मैं तुम लोग को दिखाता हूँ एग्जांपल. यू नो सस्पेंशन सिस्टम क्या होता है?
Yes.
रॉकर बोगी देखा है कभी?
Yes.
Yes. Yes.
कहाँ देखा है?
TRS के इंट्रो से.
टीआरएस के
हाँ,
इंट्रो
मतलब
से, टीआरएस के लैब में नहीं देखा है?
हाँ, हाँ,
हाँ,
मतलब
lab
वहां
में.
पहली बार देखा था, मतलब.
ओके, ये नहीं है इसके. was it this one? No. जस्ट कौन सा वाला का रॉकर बोगी हम लोग दिखा रहे थे? डू यू रिमेम्बर? वी आर टॉकिंग ना बिफोर हैंड, तुमको मैंने भेजा था एक लिंक.
हाँ, वो नोशन में डाल दिया था.
Okay, like which team was which team designed that one? किसका SAR था? हाँ
I
स्टैनफोर्ड
think ad
ओके
Astra का ही था ना.
नहीं स्टैनफोर्ड मिल गया ओके इनके रॉकर बोगी सिस्टम को देखना ठीक है लेट मी हाँ कैन यू सी द रॉकर बोगी डिजाइन ऑफ दिस वन रुक जाओ थोड़ा सा पहले दिखाता हूँ दिख रहा है
Yes.
दिस इज समवॉट डिफरेंट फ्रॉम द TRS वन TRS में
Yes.
जो बना था
Yes,
वो
yes.
बाकी लोग काफी लोग ने बनाया इवन दिस वन स्टैनफोर्ड का पुराना डिजाइन 2019 का डिजाइन का जो रॉकर बोगी है let me show you from closer यहाँ पे दिखेगा ओके Okay, this is what you have actually seen in the TRS lab. ये वाला रॉकर बोगी सिस्टम था. We had made it out of pipes. यहाँ पे metal का बना हुआ है, right?
Yes.
Yes.
So what is the loss in making this one than the other one जो मैंने अभी दिखाया था? उसमें और इसमें क्या डिफरेंस है या फिर ये क्यों ज्यादा फ्लूइड मूवमेंट दिखा रहा है? If I ask, let me show you from here. क्या है बताओ? देख रहे हो यहाँ पे आराम से ये पिकअप कर लिया. What is the difference between these two? यार बताओ यार यस और नो ही बस बोले अभी तक
Look, design different है दिख रहा है, but why exactly?
okay so normally if you are making suspension system which should work on off track right the normal car suspensions may you see the spring in the car suspension allows the wheel to go vertically upward or downward right horizontal तो
Yes.
free to move है you that is unconstrained but vertically constrained रहता है to
Yes.
reduce the like the reduce the shock what we do spring use करके we allow it कि थोड़ा सा vertically up and down it can move right
Yes.
in
हाँ.
such rocker bogie designs क्या होता है you want it to run on off terrain मतलब कि जितना बड़ा rover नहीं उससे बड़ा वो rock पे चढ़ जाए you want that right so the suspension
Yes.
system should also be like allowing that much amount of vertical distance traveling
Yes.
है ना अब जितना ज्यादा तुम्हारा वर्टिकल मूवमेंट अलाउ करेगा बिकॉज यू कांट मूव इट इन्फिनाइटली अपवर्ड मैक्सिमम हाइट ऑल्दो इसको भी फ्लैग की तरह मैं सीधा खड़ा कर सकता हूँ बट इफ आई ऐड डिफरेंट कंस्ट्रेंट तो पूरा का पूरा तो ऊपर नहीं जा सकता बट आई स्टिल नीड द मैक्सिमम अमाउंट ऑफ डिस्टेंस वर्टिकल डिस्टेंस फॉर इट टू मूव अप और डाउन सीढ़ी चढ़ना है या फिर बॉक्स चढ़ना है so it wants to move upward all the tire should move vertically up or down right तो वहां
Yes.
पे ऐसे टाइप के like then we change the rocker bogie design इवन अलग अलग टीम्स ने अलग अलग रॉकर बोगी के लिए चेसिस बनाया है सस्पेंशन सिस्टम बनाया है so these are the places where we have to like deeply think about the linkage even before we start the CAD design समझे so how you guys design this रॉकर बोगी का भी आता है लिंकेज डिजाइन तो there are a few designs यहाँ पे भी दिख रहे होंगे, there are 8 wheel designs. काफी लोग 4 wheel design करते हैं. This is what we used to design our rocker bogie. तो hobby projects के लिए this is good enough. But अगर critically we have to think, तो अच्छे से इसको डिजाइन करना पड़ता है. There is that is where we need linkages. ठीक है? Anyone any doubts?
But like I couldn't understand कि मतलब आप ऑब्जेक्टिवली कैसे कंपेयर करेंगे बनाते टाइम, लाइक बाद में आप कंपेयर कर सकते हैं कि okay, this one is more efficient, but like how will you objectively think of a new design which
Most of the time पूरा डिजाइन नया नहीं सोचना होता. There are फॉर एग्जांपल जो मैंने तुमको दिखाया था जो linearly मूव कर रहा था.
you were
Like,
not audible for some time in between. Or is it just me? I mean,
till where did you hear that?
starting से जब आप just बोलना start.
So basically linkage system में there are already some standard linkages which are built up by other people. ठीक है? उसमें से कुछ
So
choose करना. Yep.
तो अभी एग्जैक्टली ये स्टैनफोर्ड वाले जो यूज कर रहे थे, इज इट अ स्टैंडर्ड डिजाइन दैट एवरीवन यूजेस, एंड
Yep.
इफ इट इज
Yep.
देन व्हाई डज एवरीवन यूज द डिफरेंट वन दैट वी हैव बिल्ट?
तो
लाइक हर
first
जगह
thing
अगर ये
तो
ज्यादा एफिशिएंट है.
नहीं see, सेम चीज करने के डिफरेंट वेज होते हैं. फर्स्ट थिंग. सेकंड थिंग, not every team has 6 wheels. Third thing, not every team has actually thought about this. You have to understand कि काफी लोग बोलते हैं कि यार रॉकर बुक डिजाइन करना है and they just design whatever they see as their references. ये भी होता है. So मतलब कि if you ask कि कौन सा डिजाइन हम लोग को चूज करना चाहिए, we might not as well make the best variation possible. But designing, like while engineering anything out of it, it is very important for you guys to understand how we came up to this thing. If you want to revise something, like let's just say कि कुछ हम लोग design किया, we put it on the competition, we found out it is not working out. You will come back. If you have not engineered it, you will just go into arbitrary direction कि कहाँ what should be improvised. But if you know कि what was the basis of your suspension system and how can you change that completely, redesign that, like you would actually see a lot of teams कि पिछले बार का डिजाइन कुछ और था, इस बार का डिजाइन कुछ और है, they have improvised their design. So that happens because you know the fact कि how things are designed. Now here बैठ के I am not like doing the linkage design myself because I know कि there are different designs. I have not seen everything. Whatever I have seen, I will pick the best out of that. ऐसा होता है. You just need to know कि ये डिजाइन का रूट क्या है. What are the roots of the thing which you are designing, so that you can change it or like fundamentally like replace it with something else. ठीक है?
Yes.
Anything else? Anyone any other doubts? You learned about forward kinematics, you learned about move it. Now you are learning about linkages. सब चीज कैसे एक दूसरे से connected है. Did you get that?
Yes.
Yeah.
Yes.
Yeah.
So अच्छा, tell me this. You guys learnt about the transformation matrix. The assignment which I gave you yesterday. How many people have done that?
I was able to finish the three joints. I didn't know how to do the four joints one.
3 degree of freedom में fourth joint कहाँ से आया?
Like in the tutorial sheet, you mentioned a bot with three joints and four joints.
Okay, okay. Fourth joint वाला piece मारो. That was initially planned. आज के बाद जाके that was going to come up. ठीक है. Can any one of you share your screen and show the code? कैसे work कर रहा है? And those who didn't, क्या हुआ भाई? मुशीर, गौरी, आद्या, ध्रुव, दुर्वा. What is the problem?
एक आधा हुआ है पूरा कोड उसका कंप्लीट नहीं हो पाया वो मैं डायग्राम उसका बना लिया था बट कोड नहीं हो पाया फिर
Okay. Then copy में बनाओ. Click a picture, put it on Notion. Gauri,
I haven't watched the video yet. I mean, yesterday's recording is yet. I was like a problem happened yesterday, so
okay. I will talk to you later then. Adya, your voice is not coming. Durva, what was the issue? Why did you not do the thing, assignment? Am I audible? Okay. Can you text key what was the issue? Why were you not able to complete the assignment? तब तक कोई एक already presented present the code. कोई भी एक volunteer करो. All right.
Is my screen visible?
Yep.
So this is the code. First, it will ask the values of x, y, z in the L1, L2, whichever it is required. And then I derived the formula for theta 1, theta 2, theta 3. Theta 3, I think I will be able to explain it better using the diagrams I draw, but I used an example, very simple example, and it was giving me right answers. And I also cross-verified it with ChatGPT, and like it was also correct.
Okay. ChatGPT से पूरा
These
नहीं ना बना लिए.
नो आई मतलब पहले पूरा कोड हम लिख लिए फिर लाइक कुछ एक आध बार रन करके देखे इफ देयर वाज एनी एरर लाइक जैसे ये वाली चीज थी ये मेरे को चैट जीपीटी ने सजेस्ट करी कि ताकि आर्क साइन के अंदर की वैल्यू -1 और 1 के बीच में रहे उसलिए तो एक आध चीज चैट जीपीटी ने सजेस्ट करी
Okay.
थी बट हाँ
हाँ.
मेन
हाँ.
लॉजिक जो था वो मैंने खुद ड्राइव किया था थीटा 2
All
थीटा
right.
3 मतलब सबके लिए
Right. Did you guys submit? ये कर लिया ना submit Notion पे.
हाँ हाँ ये नोशन पे अपलोडेड है
All right. सब लोग एक बार upload कर देना. If you have done the written part at least, like diagram भी बना के if you have visualized it, put that on. I'm not forcing you guys here to do the task till now. Even जो day 0 को मिला था, did you guys do that? Did you guys read the rule book?
I
किसने
read
किया?
the rule book. I've just not completed the summary wala part.
Okay.
I
Others?
read it completely.
Same. I'm actually was pretty busy today. I finished the task a little late. I've finished some part of reading of the rule book, not completely, but I'll complete it by tomorrow for sure.
Okay. So there are a few things regarding the assignment thing. Day zero का the 48-hour deadline वाला assignment. I need you guys to complete that by tomorrow. Tomorrow onwards, Tantre should be taking your classes like tomorrow onwards, नहीं, कल का at least he would be taking up and he would be more serious about this. Uh, meanwhile, the first one, जिसने अभी तक डिजाइन नहीं किया है 3 degree of freedom का कोड, I want you guys, and assignment for today would be to create a 6 degree of freedom code using the transformational matrices which was taught by Hitesh. ठीक है? Do you find it feasible enough to complete it in another 24 hours? बोलो सिद्धार्थ.
सॉरी, आपने आज क्या मतलब आज का असाइनमेंट क्या बोला था? 6 डिग्री ऑफ फ्रीडम वाला एक बार प्लीज रिपीट कीजिए.
I told कि like the yesterday's assignment you had to design a 3 degree of freedom bot, right? For now,
Yes.
the next assignment is to make a 6 degree of freedom robotic arm using the transformational matrices concept, the analytical method. You can do
So
that.
like